the JEE Mains part of the common test. Okay, JEE Mains paper of the common test. Just go through the questions and tell me if there's any doubt in question 1 or 2. If anybody has a doubt in question 1 or 2, just let me know. I will discuss. Okay. All right. So I'm assuming question 1 and 2 are clear to all of you. Okay. The numbering of the question will be different compared to what it was in your test. Okay. But I think if you just go through the question, you will recognize it. Yeah, that's okay, Dhruv. Don't worry. Nobody will annotate. Okay, what about question 3? Is this one clear to all of you? Question 3, okay. So in question 3, see, what you have to understand is that when you make the free body diagram for the 2 kg block, when you make the 2 kg blocks FBD, you can see the force from this side is 10 newtons, but the acceleration is only 2 meters per second square. That means there is some force from this side also. Otherwise, the acceleration would have been 5, no? So that means there is some spring force Kx, which is the tension in the spring, which is equal to how much? Now you can find out. So 10 minus that tension is equal to 2 into 2, mass into acceleration. So that tension is equal to how much? 6 newtons. So now you make the 3 kg blocks free body diagram, and you understand that on that there is a tension acting in the opposite direction. Okay, because the spring is stretched. So it will have some acceleration, let's say E2 or whatever. So that T will be equal to M2A2. So that from here this 6 Newton force will become equal to the mass, which is 3 kg, into the unknown acceleration. So from that we will get the acceleration. Yes, order of the questions in your paper is different. That's why I said just recognize the questions, because here I have selected out the questions which are from friction and laws of motion only. Okay. If there are any doubts from the questions in kinematics, you can later send them to me. Okay, I will. Just Nikita had a doubt in question 2. I'll come back. Is this question clear to you, Vineet? Question number 3 is clear. Okay. So I'm just clearing this. Hope you're, yeah. So Nikita will come back to question number 2. I'll explain. Okay. So in this question, basically you have to use virtual power method too. I mean, virtual power method will be the easy method of calculating the constraint relation. So the block B is moving downwards with a velocity of 10 meters per second. And at that instant, you have to find the velocity of block A, which will be like this. Okay. So understand that tension is acting like this, and the same magnitude of tension is acting everywhere. So on the block B, there's a net tension of 2T acting upwards. You can see that 2T, and its velocity is Vb equal to 10 downwards. Okay. And on the block A, thing is a little bit complicated. The tension is acting at that particular instant. The tension is acting at an angle of 37 degrees with respect to the velocity. So this angle is 37 degrees, right? So virtual power minus 2T into 10, okay, plus T into VA cos 37 should be equal to 0. Okay, so this is the net power delivered by tension, which should be 0. So this is telling you that minus 20 plus cos 37 is 4 by 5 VA is equal to 0. So VA should be equal to 20 into 5 by 4. So it should be equal to 25 meters per second. So hence the answer is B. So this is one of those tricky type of questions which becomes very easy if you know how to use virtual power method. It's very complicated if you use calculus. And also try it by the thread length conservation, but in that you will have to take the horizontal displacement of A as x, the vertical displacement as y for B, and then relate with the dx by dt with dy by dt. so it will be a little bit complicated. Okay, so hope the method is clear. Okay, so this type of question is specifically designed in such a way that you should use the virtual power method. It's the easiest way of solving. Okay, so I'm clearing this now. Okay, hope this is clear. I mean, I'm clearing the solution. Okay, so that is done. Third question is done. Let's move on to the fourth and fifth question. So I think these are fairly standard questions. If you have any doubt, please let me know in any of the parts. I think they should be pretty clear. Simple free body diagram based thing only. Fourth one, okay, Vaishnavi. So you have to find in which of the following cases the contact force between A and B is maximum. So each of the cases you just calculate the contact force. ना? तो यहाँ पे देखो क्या हो रहा है? There's no friction. So the common acceleration of the system will be how much? It will be 30 newtons divided by sum of masses. Okay, and what is given about the masses? Masses of A and B are both 1 kg each. Okay, so 1 plus 1. So this will be the common acceleration. Okay, so 15 meters per second square. Now from that you know that what is the contact force on B. So this normal reaction will be mass of B into acceleration. Okay, so it will be 15 newtons. So in the first case you know that the contact force is 15 newtons. Okay, but like that in the second case you see just from A's free body diagram you will understand. इस पे 2 newtons ऐसा लग रहा है. A's own weight is 10 kg. I mean 10 newtons. So what will be the contact force here? It will be 12 newtons. Okay, so in this case N is 12. Okay. Similarly, in this case, you see A's free body diagram. There is weight plus there is also pseudo force. Okay, so there is weight of this thing. कितना हो जाएगा 1 into 10, 10 newtons, and pseudo force will become 1 into 2, so that's 2. So again, the normal reaction here is coming out to be that much only. It's coming out to be 12. So this also has normal reaction 12. Okay, and in this case, the system has an acceleration of 10. So you make the free body diagram, for example, of the block A in the non-inertial frame, which is moving with an acceleration of E equal to 10. So in this frame, this is at rest because the pseudo force acting on it is getting balanced with what? Normal reaction. So the normal reaction is mass of A 1 kg multiplied by acceleration 10 meters per second square. N will be equal to Ma, which is the pseudo force. Okay. So again, it is 10. So in this case, the normal reaction is 10. So this case, the normal reaction was 12. This case, it was 12. This case, it was 15. So here it is maximum. So this is clear, Vaishnavi? Okay. So can I clear the drawing? You are clear with everything? Okay. Good. Let's move on to fifth question. Anybody has a doubt in fifth? Okay, good. So I think it's a pretty standard question. So well practiced in this. What about this question? Any doubt in this? Simple virtual power method or virtual work method you can use. Okay. So you have to actually sit and find out the acceleration of the block B in this case. So you have to use the constraint relation as well as the free body diagram method. So sixth question, any doubt, people? Okay, good. So let's move on to, yeah, okay, good. So let's move on to next set. Seventh question about limiting friction, minimum acceleration of this so that they are in contact. Any doubt in this, people? Okay, good. Yeah, Harpriya, you have a doubt? We'll discuss. Okay. So see, in seventh question, what is happening is that you are giving this some acceleration so that this one's relative acceleration is at rest. We want that relative motion between small m and capital M should be 0. There should be no motion. Okay, so that means if you are standing on this frame of capital M, so you become a non-inertial frame. In your frame now, what should happen to this block? This block should be at rest. So in your frame, what are the forces acting? There is pseudo force, okay, that is creating contact with the wall. So normal reaction, mg is pulling it down, and if it is at rest, there is static friction. So static friction should balance mg. That's your first equation. And normal reaction is equal to pseudo force. That's your second equation. And the limiting condition on friction is that static friction should not exceed mu n. So from equation 1, how much static friction is required mg. From equation 2, how much normal reaction is available to us mu a. So what is this telling us? That a should be greater than equal to g by mu. So the minimum amount of acceleration required, that just becomes the equality condition g by mu. So assuming g mu is less than 1, so it will be an acceleration greater than g. Okay, so for example, if mu is equal to 0.2, then the minimum acceleration you require is actually 5g, so that the contact force is enough to be able to create friction to prevent slipping. So hope this is clear, Harpriya. So main thing is the, okay, very good. So main thing is the free body diagram in the non-inertial frame, because in the non-inertial frame only it's very easy to understand that this block is at rest. Okay. Okay, so I'm clearing the free body diagram. Okay, what about 8th and 9th question? Anybody has a doubt in the 8th question or the 9th question? Okay, good. Okay, very good. Fine. And I think the vectors question should be okay. I'm just 10th question, just go through it once. I think you can see the question directly. It's pretty easy. B is equal to 2 times A. So they are parallel vectors. Their magnitude is 1 is to 2. And magnitude of A, as you can see. So this is the wrong option. So D is the answer. Acha, Jenny, you have a doubt in the 8th question. Okay, I'll come back to that. Okay, so in the 8th question, what we do is we make the free body diagram. Yeah, Vinith, I'm coming back to integer questions. Okay, let me just clear the 8th question. So in 8th question, you make the free body diagram. So I'm making it with the forces resolved. Okay, so this component of force is F cos 37. So that is 4 by 5F, because cos 37 is 4 by 5. Okay, and this component of the force is 3 by 5F. Okay, so this is becoming how much? 4/5 of 75. So that is 60 newtons. This is 3/5 of 75. So 15 these are 45. So this is this much. Okay, now apart from this, what forces are acting? The wall will react by applying a normal reaction. Okay, so normal reaction will become how much? We'll just discuss in a moment. And the block's weight is how much? It is 10 newtons. Okay, because g is 10 and mass is 1 kg. Okay, so normal reaction will be equal to F cos theta. So it will be equal to 60 newtons. So normal reaction will be 60. So now we have to see whether or not the block will accelerate. So what is the net force which is acting? It's acting upwards. So net tangential force is how much? It is F sine theta minus mg, which is working out to be 35 minus 10. So 25 newtons is the amount of tangential force. This is giving it a tendency to slip. Okay. Whereas what is the maximum friction available to us? That is mu n. Okay. So mu kitna hai? 0.25. So it is, this maximum friction is 0.25 multiplied by 60. So that's 1/4 of 60. So it's only 15 newtons. Okay. So that means there is slipping. So this thing you can see what is telling us now, that the tangential force is greater than maximum friction. So it slips. So here, which type of friction will be acting? Kinetic friction equal to mu n. And what will happen is that the block will have an upward acceleration E. So our equation will become F sine theta minus mg minus kinetic friction is equal to ma. Okay, so that will tell us that F sine theta minus mg minus mu n is equal to ma, and n is further equal to how much? F cos theta. So we'll get this relation that A will become F sine theta minus mu cos theta minus mg divided by m. Or we have already calculated the things over here, so it's quite fine. So it is 25 minus 15, which is 10 newtons, divided by the mass, which is 1 kg. Okay, I've made some mistake, is it? Or is the answer wrong? Oh, sorry, my mistake. This is 45 minus, okay. This is 45 minus 10. So this should be 35. So the net tangential force is 35. So ये कितना हो जाएगा? 35 minus 15, 20. Okay. Yeah, so the acceleration should be 20 meters per second square. Okay. So please note that I made a correction here. Okay, and a correction here and here. Okay, good. So Jenny, this question is clear, beta? Okay, good. So can I clear that diagram? It's the free body diagram, everything is clear? Okay, very good. So next, let us move on to the integer questions. Yeah, so Vineet, you had a doubt in the integer one, no? Okay. So see what is happening. You have to first of all understand what is the tension in the spring before you burn this thread. So before burning the thread, what was the free body diagram looking like? There is spring force Kx, or you can write that as tension T1, whatever. There is tension in this thread T2, okay, and there is mg. So it's quite easy to calculate. We can just use equilibrium of three forces concept. So basically, I want to find out T1. So Kx or T1, whatever, upon sine 90, because this angle here is 90, okay, should be equal to mg upon sine of this angle. So this angle is 90 plus 53, so 143 degrees. Okay. Okay. So my tension Kx will become equal to how much? Mg upon sine 143, which is the same as sine 37, so 3 by 5. So 5 by 3 mg. Okay. This. So now after you burn the thread, what is happening? After burning the thread, this force at that moment remains the same. Okay, so just after the string is burned, at just that moment, this kx is still acting at the same angle of 53 degrees, and mg is acting like this. Okay, so what will happen is that it will have an acceleration in this direction because the sum of these two forces will be in this sort of direction. Okay, and that kx's magnitude will remain 5 by 3 mg. Okay, so you can see the vertical component of kx will balance this, and the net force will be the magnitude of this mg plus kx. Okay, and from that you'll get mass into acceleration. Okay. However, there's an easier way of doing this question, and I'll tell you the easier way of doing the question. You can see that here as a vector quantity now, what is happening? T2 is basically minus of mg plus T1. Just calculate how much T2 is. Okay, so T2's mod is mod of mg plus T1. So that is equal to how much? Now from here you can equate that also. No? It is T2 divided by sine of 180 minus 53. So that is how much? 127 degrees. Okay. So that is, so that tells you that mg upon 3 by 5, okay, is equal to T2 upon 4 by 5. So T2 is equal to how much? T2 is equal to 4 by 3 mg. So you substitute that here. Okay, so this is 4 by 3 mg. So now this is very easy. So you substitute that here. So you see this thing is actually 4 by 3 mg. So that should be equal to ma. So A should be how much? 4 by 3g. So this is a little trick you can use. You had equilibrium of three things. So that means the magnitude of one of them is equal to the magnitude of the sum of the other. Okay. So now later what you're doing here is you are actually calculating how much this is. Okay. So that is nothing but magnitude of E, which you have calculated from here. Okay, so this is a little trick that I'm using. Nikita, is it clear now? Okay, so what I have to do is I have to calculate the vector sum of kx and mg, but I can use this little trick that the vector sum of kx and mg has a magnitude equal to T2 only. And what was T2 before the string was burnt in the first diagram. Okay. So in the first diagram, whatever is the value of T2, that is the value of the vector sum of these two in the second diagram. Okay, this is equal to actually T2 in diagram 1. Okay, so that is it. Okay, so Vineet and Nikita, hope this is clear. And if it is, can I clear the board now? Can I clear the diagrams? Okay, okay, finish it. Okay. Yeah, using vector sum बेटा ऐसा करना पड़ेगा, ये angle निकालना पड़ेगा ना. So now you'll have to use that triangle law, that root of mg square plus इसका magnitude क्या है 5 by 3 mg square plus 2 times ab sin cos theta, that thing. So put the value of a as mg, b as 5 by 3 mg, and theta will be this angle, so it will be 127 degrees. So it will become a little lengthy, but that would be the vector algebra way of solving. Anushka, is it clear, beta? Okay. Okay, I think this was a pretty simple question. So if anyone has a doubt, let me know. Otherwise, we'll move on to the advanced paper. Okay. So people, I'm just going to share the advanced paper. Just give me a moment. Okay, so let's start with question 1. Anyone has a doubt in question 1? Okay, okay. So let's discuss. So here you see, you have to remember that the pulley is attached to the block. Okay, and it's rigidly attached to the block. So whatever forces are acting on the pulley now, those forces are acting on the block. So you're you're pulling with a force P on this thread. So the tension developed in the thread, that tension is equal to how much? That's equal to P only. Okay. So now if you look at the block's free body diagram, what all forces are acting on the block? So on the block there is, I'll break mg into components. Okay, so there's mg cos theta, mg sin theta. Okay. Now there is this tension which is interestingly acting at that same angle theta as this angle is. Okay. And then there is of course normal reaction, and this is just about just begins to move. Okay, so that means, let's say the acceleration is tending to 0, but it's moving, so there is kinetic friction of mu n. Oh, sorry, it's a frictionless plane, so my mistake. So it's don't need to worry about friction. Okay, so these are the forces which are acting on the block. So now you have to just balance now. So minimum force P, so T plus T cos theta has to be just about greater than equal to mg sin theta. So you can see T into 1 plus cos theta should be, if I'm writing this as minimum, then it will become equal to mg sin theta. Now you have to do a bit of solving here, because you can see that none of the options are matching directly. So you have to use the half angle formula. Okay, so this thing sin theta upon 1 plus cos theta, इसको ऐसे लिख दो 2 sin theta by 2 cos theta by 2, and 1 plus cos theta can be written as 2 cos square theta by 2. So this becomes how much? 2 cancels, cos cancels, so this becomes tan theta by 2. Okay, this becomes this. So here we are using the additional formula that cos theta, sorry, cos theta can be written as 2 cos square theta by 2 minus 1. So additionally, this formula I'm using here. Okay, so that is why option A will be correct. So hope this is clear, people. So actually, this is not that tricky a question. I initially thought there's friction, so it would be a little bit more tricky, because normal reaction here is also affected by tension. So you can do this question again by taking a friction wala case. It will be a more interesting question. Do a part 2 version of this question where the surface is having friction. Okay. Okay, so hope this is clear. Okay, so I'm removing the drawing now. Okay, hope all of you are clear with the free body diagram. I'm removing the drawing. Yes, if I include mu, then you have to include friction. And why the question becomes interesting, Tanishq, is friction depends on normal reaction, and normal reaction will also be affected by tension. So here you can see that normal reaction is equal to how much? It is mg cos theta minus t sin theta. So further complication comes in. So that's why the question will become interesting. So you try it out. Okay, required you discuss with me. Okay, now moving on. Second question I think should be pretty easy. Okay, just make a FBD and break the rope into two parts. So you can make the FBDs accordingly. Okay, let's come to third question. Third question should not be confusing actually. It's just about getting the free body diagram right. It can be a little tricky in terms of, so let me just magnify a little. Yeah, I'm discussing question 3. Just give me a moment. Just want to magnify the diagram. Okay, so what is happening here is that if the system is in equilibrium, then we have to find the relation of theta. Okay, so you have to understand that let this string, by symmetry, it will have the same tension on both sides. So let's take this tension as T1, and then this other string, let's say it has a tension of T2. Okay, so you take this point as P1, So at that point, net force should be 0. So there are two tensions, T1 and T1, acting like this, such that they are actually perpendicular to each other, and these angles are 45. Okay, and that is balancing the weight of the smaller block that is creating tension at the point P1 downwards. So you have how much? T1 root 2 is equal to small mg. So that's your first equation. Okay. Then you come to this point's free body diagram, this point P2. So वो point P2 पे क्या हो रहा है? There is this T1 which is acting like this at an angle of 45 degrees, and its magnitude is also known to me. Then there is the weight of this particle or block or whatever, capital Mg, acting vertically downwards. And then we are applying the tension T2 at some unknown angle so that there is equilibrium. So let's say this T2 is like this, okay? And this angle here is the unknown quantity theta. So since we have to find theta here, I would not advise to use Lami's theorem. Okay, though you can actually, but what I would advise is just break this into components. So क्या हो रहा है, इसका जो horizontal component है वो कितना होगा, T2 sin theta, that has to balance, oh sorry, I've taken the wrong angle as theta, so I'll get the complement. I should take this angle as theta, same as the question has taken. So okay, so T2 sin theta is the vertical component, so that will balance what, capital Mg. Okay, so again I have to be careful with the symbols. Yeah, so that is balancing capital Mg plus T1 sin 45 or T1 by root 2. So that's your second equation. And T2 cos theta, which is the horizontal component of this one, that should just balance T1 by root 2. So that is your third equation. Now what you do is substitute this over here. Okay, substitute all this over here. So your second equation will become like this. Now second equation will become T2 sin theta is how much, ये mg by root 2 है, so by root 2 करके mg by 2 हो जाएगा. So it will become capital M plus small m by 2 into g. Okay, and your second equation will become what, T2 cos theta is again T1 is mg by root 2, so m by 2g. So now just divide the two equations. Equation 2 divided by 3, so you'll get tan theta equal to 1 plus 2 times capital M by small m. Okay. So this was not really a difficult problem. It was just about being very patient with making the free body diagrams and substituting the equations. But anyhow, hope it is clear now. Okay, very good. So can I clear the diagram, people? Okay. Okay, good. So let's move on ahead. Just a minute. Fourth and fifth question, anybody has a doubt, let me know, please. Okay, fifth question, we'll come to that. Okay. Just a second. Sorry, I meant question number 2, right? You have a doubt? Achha, question 1 also. Okay. Yeah. Okay. Okay. So we'll discuss both of these. Okay. So now the first one in more than one option. So what is happening? A man is pulling a block heavier than himself using a light horizontal rope. Coefficient of friction is the same between the man and the ground and between the block and the ground. Okay. So let's say the man applies the force F on the rope. So that becomes the tension. Whatever force is applying, that becomes the tension of the rope. So his body experiences tension, friction like this, let's say, whereas the block experiences tension and friction F2. Okay. So now the block will not move unless the man also moves. Let's understand this. So for the for block to move, okay, T has to be greater than mu capital Mg, that is F2 max. Okay, that is the required condition. Well, let us say this is capital M and this is small m. Okay, and capital M is greater than small m. Okay, so that automatically means that tension is greater than mu small mg. Okay, because F1 max is that much and M is smaller than capital M. So if T is greater than this, it's greater than this also. So that means the man will definitely move. So the moment you are applying a tension or applying a force creating tension greater than the limiting friction on the block, definitely you will have to move because the tension that is pulling you towards the left, that is greater than the limiting friction that you have with the ground. So option A becomes correct. Okay, is this clear, Nikita? This part? Okay. Now the second option, man can move even when the block is stationary. Yes, that is also true. Why? Because see, for the man to move, you need the tension to be greater than mu small mg. Okay. But tension may be greater than mu small mg, but at the same time less than mu capital Mg because m is less than capital M. So this is the condition that the man will move, but the block will not move. Okay, so that's why this can also happen. Is this clear? Okay. Now let's see why C is correct. Okay, C is obviously correct because the acceleration of the block E1 and the acceleration of this A2, this will be mu capital Mg, because it will be kinetic, and this will be mu small mg because this is also kinetic now. So acceleration of the block will be whatever tension minus mu capital Mg divided by capital M, and A2 will be T minus mu small mg divided by M, divided by small m. Okay. So now if you compare these two, this is T by capital M minus mu g, and this is T by small m minus mu g. Okay, so you can see that this quantity is larger than this. So therefore E2 is greater than E1. So the man's acceleration will definitely be more than the block's acceleration. So if both are moving, then the man's acceleration will be more than the block's acceleration. Okay, good. Let's move on to the next question then. Second one. So in this, what is happening? Horizontal surface is smooth of the block M0. So this surface here is smooth. Vertical surface is rough. Okay, with a coefficient of friction mu. Okay. Okay. Now what all we have to do in the question, let's understand that first. So what will happen if the force F is 0 and we apply 0 force here, then there will be no contact between this and this. There won't be any normal reaction, and there's no friction here. So this will simply come down, this will simply move like this, and that E will be mg divided by m plus m. Okay. So this is becoming a wrong option. Okay. Now, for one unique value of f, the block m and m remain stationary with respect to m naught. That is also wrong, because see, the moment you are applying some force, this block has some acceleration, let's say a naught. Okay. So the free body diagrams of the other two blocks in the frame, in the non-inertial frame, which is traveling with a naught. So in this frame, this block and this block have what forces acting on it? They have pseudo force. Okay. Then tension. Okay. Then normal reaction. Okay. Then their own weights. Okay. And in the case of this one, friction. So what we will understand here is that if capital M A naught dominates over small mg, so then the tendency for slipping is like this. So friction will act down the inclined plane. I mean down the vertical. So in this case, what will happen? Static friction will act like this. Whereas on the other hand, if mg is greater than ma naught, then the tendency for slipping is like this. So in that case, the friction on this will act like this. So there's a range of forces. Okay, so there's a range of values of a naught for which there's equilibrium. So that means there's a range of values. F should be greater than a minimum and less than a maximum. So this option becomes wrong. Oh, it's written it cannot remain stationary. Yeah, it's correct option then. Yes. And option A is correct. Yeah, thanks for pointing that out. So the option is saying that if F is equal to 0, the blocks cannot remain stationary. So this is correct. But option B is becoming wrong, because there is a range of values of F, not one unique value. Okay. Now the third thing, the limiting friction between M and M naught is independent of F. That is wrong. Why? Because this limiting friction, this depends on this mu N2. Okay. And N2 is nothing but M A naught. And A naught depends on force. Okay. So you can see, because this depends on force, obviously the limiting friction depends on capital F. Okay. Okay. Now let's come to option D. Now option D is very interesting. It says that there is a value of F, okay, for which the friction force required is 0. So what will be that value over here? You can see from this diagram, you can see that if capital M A naught is equal to small mg, then there is no tendency to slip. Then what will happen? In this diagram, the tension will become equal to small mg, which will be equal to capital M A naught, and there is no tendency to slip. So there won't be any friction. Okay. But that will happen for a unique value of A naught. Okay. So that will happen for A naught equal to small m by capital Mg. Okay. So that is a unique value of force. It is equal to the combined mass into that value of acceleration. So that is why this option is also correct end of the day. Okay. So this type of question, now you need like experience with solving problems of this type, which are lengthy numerical problems. Okay. So then when you've done the analysis with those lengthy numerical problems, then you understand the options much more easily. Whereas if you're solving a question like this from scratch, it will take you as much time it would take to solve the actual lengthy numerical problem. So if I had given you the three masses and the coefficient of friction and some force, and I asked you to calculate, it would have taken a lot of time to solve this question. So while doing the MCQ, it will not take so much time if you know how to solve that problem. But if you don't know how to solve that problem, then you will get stuck. So this is why it's very important for JEE Advanced that you do some good quality subjective questions also. The type that are there in your module, the type that are there in HC Verma also. The last 10 or 12 questions in every chapter in HC Verma, it will give you that kind of practice that is required for doing these MCQ questions. So थोड़ा सा यहाँ पे this becomes contradictory कि ऐसे objective questions को करने के लिए only practicing objective questions will not help. Okay, you have to learn how to crack the lengthy type of numerical problems, the subjective type of numerical problems. Then doing this type of MCQ questions becomes easy for you. Okay, it is a bit like saying that if you are capable of playing a lengthy test match innings, then you can do well in T20 in certain situations, like when the pitch is bad or something like that. So it's a bit like that. If you have a tricky question like this, it is your experience in doing lengthy numerical problems that will help at the end of the day. Okay, tricks and shortcuts for objective questions, value substitution, all those things will not help in these type of questions. It can make you go horribly wrong. So your fundamentals and your analysis of typical questions, very conceptual questions, that becomes important. So limiting friction is one of those topics where you need to do that. You need to go in a lot of depth. Okay. So I'm going to give you some revision exercises after you finish the module exercise also. So even when we are doing work by energy, the next chapter, you will keep doing some practice questions and the higher level difficulty level practice questions in friction and Newton's laws also. So that process will continue for you. Okay, so I'm clearing this now. Hope this is clear to all of you. Yeah, this question is clear, right, to all of you? Okay, good. Right, so let's move on to the next one. So this is again a conceptual type of question in vectors. Go through question 3, let me know if there's any doubt. Non-coplanar vectors. So keep that in mind. Okay. So let's move on to passage type problem. So again, this is a typical two block type of problem. So I think if you just follow the methods that we've discussed in class, you should be fine with it. Anyone has a doubt in the passage question? Okay, good. Okay, Snigita and Harpriya will discuss. Okay. So what is happening here? See, you are applying the force on this, the coefficient of friction here. Okay, so let's first of all label these blocks as A and B. And what is going to happen is the moment I apply force on this block, there'll be friction on A acting like this. So on B, that same friction will act like this. And from the ground, there'll be friction on B, which will act like this. Okay. So first thing we need to do is we need to calculate F1's maximum value. Okay. So that is how much? That is 0.1 into 100. So that's 10 newtons. Okay. So this will be actually mu1 m1g like this. Okay. And we need to calculate F2's maximum value, which will be this coefficient of friction mu2 into the sum of the weights. Okay. So that is becoming 150 into 0.3. So that is 45 newtons. So these are the maximum frictions. Okay. So now you can see that no matter how much force you apply on this block, Okay, whatever force you apply, F1 cannot be more than 10. Okay, so F1 is less than equal to 10, independent of capital F. So now when you look at this one's FPD, the block B's FPD, this is less than equal to 10, and this can go up to a maximum value of 45. So will this block ever move? No, it'll always be 0. Okay, so no matter how much force you apply on the block A, the block B will never move. Okay, so that's the first conclusion, that whatever be the value of F, okay, the 5 kg block will remain in equilibrium. Okay, and if you want to move, if 10 kg block has to move, okay, then F has to be greater than F1's maximum value. That you can see from A's free body diagram. Okay, so F has to be greater than 10 newtons. Okay, so if the force is 15 newtons, both blocks will not remain at rest. This will move with an acceleration of how much? 15 minus 10 divided by, yeah, so 0.5 is correct. And the, yes, this is correct. Common acceleration नहीं हो सकता है, ये नहीं हो सकता है. Yeah, the answer should be B. Oh, the answer is given as C, is it? Okay, I will get this corrected. Okay, this should be B. Okay. Okay, just make a correction in the answer key here. I'll get this corrected in the website also. Okay, so hope this is clear. Then we'll come to the next part. Okay, so just remember these values here. Huh? The blocks B cannot move, and for the block A to move, we need to apply more than 10 newtons of force. Okay, so with this, let's come to the second part. Okay, so second part, let's check out. So what is happening? Minimum force. So this is not correct. Okay, no, 10 newtons and more will create slipping. Okay, if F is greater than 10 newtons but less than, so this is also not correct because they will always slip. Okay, this is the only one which is correct. This will start slipping with respect to the lower one, so option, so this one is correct. But this one, it has to be changed to B. Okay, people, so hope this paragraph is clear. I will get the answer key corrected, and don't worry about that part. Okay, now let's come to this one. This is also a very interesting question. Okay, so this, what is happening? So ignore this over here because each thing is telling you something different. So the first part, all surfaces are smooth. So if all surfaces are smooth, what will happen? This capital M and small m will simply accelerate independent of that other one. Okay, there will be nothing happening on this. In the first case, when all surfaces are smooth, okay, these two will have the common value of acceleration. Okay, and this one will be at rest. Oh, sorry, m naught is this one. This is just capital M. Okay, so what will happen? So for the first part, m naught has to remain in equilibrium. So P is correct. Okay, acceleration of m must be non-zero. Small m is which one? This one. Yes. So Q is also correct because there's nothing to stop here. No? There's no friction. So only tension acting and tension and weight acting here. Okay, so this has to move. A has to be greater than, sorry, A has to be non-zero. Okay. Then m naught must be accelerated. Okay, that's not correct. The block M may remain in equilibrium. That's also not correct. Okay. So far I'm getting P and Q, but I'll have to scroll down actually. Okay, wait a minute. I will just have to clear this, minimize this a little so that we can see everything in one diagram. Let's see. Oh, so there are these many options only. Just a minute. Yeah, right. So it should be good now. So with one, we were getting what? We were getting P has to be in equilibrium. This one has to accelerate. R and S were not correct. Okay. Now let's come to the second one. The second one, what is happening? Horizontal surface has coefficient of friction mu with respect to the block M. No friction between M naught and M. Now this is a very interesting case. Okay, so the moment that happens, see, the moment there is friction between this and this, now basically small mg has to be greater than a certain amount. Otherwise, okay, this will happen here. So equilibrium means that tension is equal to mg equals to static friction. So for acceleration, tension has to be greater than m naught plus capital M g. So if this happens, then again capital M and small m will have acceleration, but m naught will remain at rest. Why? Because this surface is smooth. The surface between the two blocks, this one is smooth. It's no friction between m naught and this. Okay. So basically, no matter what you do, this guy cannot move. M naught must remain in equilibrium. Okay. Must be non-zero. This is also not correct because this condition can also happen. So if mg is less than equal to mu m plus m naught g, then the acceleration will be zero. So this is not correct. Okay. M naught must be accelerated. That's not correct. This may be in equilibrium. That is true. So P and S become the correct options. Okay. Is this clear to all of you? Okay, now we'll come to the third part. So in the third part, see what's going to happen is, okay. So third part, what we are doing, we are making the horizontal surface smooth, and there's a coefficient of friction mu between this and this. Okay. So the moment that happens now, ये surface smooth है यहाँ पे. So this has to accelerate. Okay. But the question is whether this accelerates with the same acceleration or different acceleration. Okay. So A prime can be equal to A. That is the no slipping condition. Okay. A prime can be less than A, in which case there is slipping. But in that case, A prime will be mu g and A will be greater than mu g, where mu is the coefficient of friction between the two. So in either case, okay, this cannot happen. Okay. This has to be non-zero. M naught cannot be in equilibrium and M also cannot be in equilibrium. Okay. So this should go with Q and R. Okay. And finally, we come to the last case. So in the last case, what it is saying that there is friction at both the surfaces. Okay. and the coefficient of friction is also same for both the surfaces. So in this part, in the last part, what will happen is that these two blocks will tend to move together. Okay, so either for the fourth part, if m is less than or mg, if the weight of the hanging block, that one, is less than limiting friction on the floor over there, it is less than mu m plus mg. Okay, then what will happen? Acceleration of all three will be zero. Okay, if so, one thing we can definitely say here is that this may remain in equilibrium. Okay, if mg is greater than mu m plus mg, okay, in this case, what will happen is that either all three move together, okay, or there is slipping between m naught and capital M, because there isn't enough friction between the two of them. Okay, so this cannot remain in equilibrium. But the must remain in equilibrium is not necessary. It can remain in equilibrium in the first case, but in the second case, it can start slipping. Must be non-zero is not necessary. First case we have seen. Okay, this is also wrong. It can be in equilibrium. So only one option is coming correct. Fourth is going with S. So PQ, PS, QR, and S. These should be the correct options. So hope this question is clear to all of you people. Anyone has a doubt in any of the parts, please let me know. I'll make a more detailed free body diagram and explain. Okay, so I'm clearing this now. Okay, so anyway, so that completes the advanced paper. Right, so we can now move on to something else. So first of all, if you have any doubts in the module exercises, we can spend the remaining time today discussing some of them at least. Okay, and otherwise we can start with work energy. So just take a couple of minutes break to maybe orient yourself again and go through the module exercise and send me any doubts on the text message. Okay. Okay, Kevin, understood. Okay. If anybody else has any doubts in the module questions, just go through the module exercise once and let me know. There is one particular question that I will discuss with you in partial part today. So let me come to that. I'll discuss with you. Okay. How much of circular motion you people have done? Have you understood tangential acceleration and centripetal acceleration fully? So you fully understood centripetal and tangential acceleration? Okay, so then maybe we can discuss that question. Okay, okay, ठीक है. So just take a couple of minutes break. We'll reorient ourselves and we'll discuss one question from the module, and then we'll move on to work by energy. Right, so let's resume. Yeah, so I'll just bring up that question I was telling you about, which I want to discuss. Just give me a second. Yeah, so this particular question, so we have an inclined plane like this, let's say, that is at an angle of inclination with respect to the horizontal direction at some theta. Okay, so I will discuss these questions also. So this is question number 48. Okay, so let me discuss this one first. Now, what is happening? There is a small block, or you can treat it like a particle, which you have kept on this inclined surface. Now, the surface also has coefficient of friction, which is equal to tan theta. So it has a coefficient of friction, which is exactly equal to tan theta. Now, what we are doing is initially at t equal to 0, we are giving this a kick or an impulse so that it develops a horizontal velocity tangential to the inclined plane. So that means it develops a velocity in this direction, okay, of v naught. And we have to find over here the velocity after a very long time. Okay. So we have to understand here that gravity is acting vertically downwards like this. Okay. So what we will do here is we will take this as our xy plane, suppose. We take this as our x-axis, this as our y-axis, okay. And accordingly, our z-axis will then become like this. This will become our z-axis. So that gravity is at an angle of theta to this, okay. So I will draw the diagram in the two separate planes now. So I'll redraw this diagram in the yz plane. If I draw it, if I see from this side, it will look like this. The same diagram will look like this. So the block will look like it's over here, okay, and the forces acting on the block will be the weight, the normal reaction. And in this diagram, I will not show friction because the velocity is into the plane at this moment, okay. So what will happen is that the friction acting on it will be in this direction. There will be kinetic friction acting on in this direction. So the forces, as you can see, will be N, that is along minus k cap in this direction, mg cos theta along positive k cap, and mg sin theta along positive of j cap. These components of mg This will be active. And along with that, there will be kinetic friction of mu n, but that will act along which direction? It acts along minus I cap. So I can't see that in this diagram. So what is happening from this diagram? I can understand that n will be equal to mg cos theta. Okay, and kinetic friction will therefore be equal to mu mg cos theta. Now since mu is equal to tan theta, so therefore it means that it will be equal to mg sin theta. So this is the free body diagram from this angle. Now we are looking into this. Okay. Now let's look into the free body diagram from the other angle, like the top view. Okay. So let us look at, this was our x-axis, this was our y-axis. Let us, it's like we are seeing this from the top now. So looking directly into the inclined surface. So if your inclined surface is something like this, so this is the angle of view now. We're looking directly into the inclined surface. So where the motion has started from, this is what is happening in this view. Okay, we have given it an initial velocity in this direction, v naught. Okay, whereas the two forces that you will see in this particular angle, in this particular diagram's angle, the two forces you will see is friction and mg sin theta. Okay. So you will see mg sin theta and you will see kinetic friction. Now the kinetic friction, which is mu n, will have a magnitude of mg sin theta only. Okay. Whereas there is also, there is mg cos theta going into the plane, that is along plus k cap. Okay. And there is normal reaction coming out, which I'm not showing in the diagram, or along minus k cap coming out of the plane. So what happens here is, most importantly, you'll see that mg sin theta, it provides what we call the normal acceleration. We won't use the term centripetal here because it is not circular motion. So there's no so-called center. Okay, but it is normal, which we call an. Okay, that is the component of acceleration perpendicular to the velocity, initial velocity. Okay. Whereas friction, it provides tangential deceleration. Okay, because friction is, okay, tangential acceleration. It is collinear, in this case anti-parallel, with respect to the velocity vector. So what we are doing here is, we are talking about the general curved path. Okay, so because of this now, because there are both components of acceleration, this will follow a curved path like this. So whenever a particle has a curved path, like even in projectile motion you would have studied, so the instantaneous velocity of the particle and the instantaneous acceleration are not in the same direction. So if this angle is theta, in general you can see that a cos theta is what we call the tangential component, and a sin theta here is what we call, don't confuse this diagram with this is the general case. Okay, so this is the normal component. So what tangential component does is, tangential component is the rate of change of speed. Okay. And what normal component does is, it turns the direction of the velocity vector. So both the things are happening simultaneously. Because of the normal component of acceleration, the velocity vector next is going to turn in direction. But because of the tangential component of acceleration, the velocity vector is also going to change in magnitude. So next moment when we look at the particle somewhere here, velocity का जो magnitude है वो भी change हो गया. V prime is greater than V because tangential acceleration is positive. and also v prime's direction is different to v because of the normal acceleration. So that kind of thing is happening here. Okay. So now if we compare this, so this was at t equal to 0. Now if we compare this situation to some arbitrary time when the particle reaches here, so at some time t, so the velocity vector now of the particle is in some general direction like this. Okay. So I will just go back to maximizing. So hope the concept of normal and tangential acceleration is clear to all of you. Yes. Okay. In fact, just make a clear note, or go through this part once. The side note that I've written where I've explained normal and tangential acceleration. Just go through this part once more and make sure this is clear. Okay. So make sure this part is clear. Then we'll review the free body diagram above also once. Then we'll come back to this. Because once the free body diagram has become clear, now this becomes more of a kinematics problem. So we will solve it using kinematics principles. Okay. That is, acceleration is rate of change of velocity. So change in velocity is integration of acceleration. Those kind of principles we'll be using. Okay. So just make sure that these equations are clear to you first, the ones on the side, and then we'll come back to the free body diagrams. Let me know if there's any doubt in any of these. Okay. Now just go through this above free body diagram and this one also, both of them. So you understand what's happening with respect to this 3D diagram. Okay, this is the three-dimensional view. This you can think of it like the side view, and this is like the top view. Please understand the correlation between these three. Then we will continue. Okay, so now once the initial free body diagram is clear, now what we have to do is we have to understand that this was at t equal to 0, when the velocity vector was along the positive x direction. But from there, what's happening at a general time? So at a general time, what is happening is this. So I'm showing you next. So after some time has progressed, because that normal acceleration क्या कर रहा है, वो velocity को continuously ऐसा turn कर रहा है ना, so the velocity vector will keep turning from the x axis towards the y axis. So after some time the velocity has become like this, and its magnitude has also changed. And from the diagram you will understand that the magnitude of v has become less than v naught, because what will happen, kinetic friction. Now let's see the forces in the same diagram. Let's see the forces. So kinetic friction keeps adjusting itself according to the velocity. It always acts opposite to the velocity. Whereas mg sine theta, that does not adjust. That always acts along the y-axis. Okay. So here, this is mg sine theta remains like this, whereas kinetic friction becomes like this. Okay. So now let us also see that. So let's say this angle is now theta. Theta is, we can't use the term theta because theta is already there. So we'll use some other term instead of theta. So let's use the term, let's say beta. Okay. So beta is, you can say, the angular deflection. We can say deflection kya hai? It is the angle by which the velocity vector has turned or deflected. Okay. From t equal to 0 to t equal to t. So in the diagram you can see that beta is continuously increasing. So now if I write FBD equation, so hope this is clear to all of you, है ना? So because of the normal acceleration, ठीक है, तो क्या हो रहा है यहाँ पे velocity vector पे tangential deceleration भी act कर रहा है, velocity tangential acceleration भी act कर रहा है, sorry, tangential deceleration भी act कर रहा है, normal acceleration भी act कर रहा है. So tangential deceleration is making this reduce in magnitude. Okay, so this is happening because of the tangential deceleration. Okay, which friction is providing. Whereas ये जो turning हो रहा है velocity का, okay, it has turned through an angle beta. This is due to the normal acceleration. Okay, so now if I want to write the equation for free body diagram at the general time t, okay, so for t equal to t for this instant, okay, this was for t equal to 0. This was at t equal to 0. Now I'm writing for t equal to t. So in this diagram you can see that if I draw this, this is the direction which is normal to the velocity vector. Okay. So this angle is beta here. Okay. So mg sin theta का cos beta component क्या provide कर रहा है, normal acceleration. So that is not actually important to us, but mg sin theta का जो cos beta term है, sorry, जो sin beta term है, so mg cos sin theta's sin beta component, that is along the velocity vector, and friction is opposite. So this is the tangential force. So this is providing the tangential acceleration. What is the net force along the velocity vector? It is mg sin theta's component along v minus kinetic friction. So this second equation is the one that becomes important for us. Okay. So make sure these two equations are clear to us. So what this is doing, the normal acceleration, it makes the velocity keep turning in direction. It keeps deflecting. But what the tangential this thing does, it makes the body actually, because here this tangential acceleration will be negative because friction will be more than this. Okay, so this at will come out to be a negative quantity. So uske वजह से the object keeps slowing down. Okay, so we will write an equation for this, and then we will also try to relate that after a long time, what is it that we expect happens. Okay, this is at some short time between when the motion has started at t equal to 0 and a little bit of time later. But if we look at the same thing after a sufficiently long time, and of course, assuming the inclined plane is also very big, so the particle doesn't reach the bottom of the inclined plane. Okay, okay, so this equation now, this will tell us that firstly in this kinetic friction, which is mu n, is equal to tan theta into mg cos theta. So it was equal to mg sin theta. So this equation converts to mg sin theta sin beta minus mg sin theta, because kinetic friction is equal to that only, is equal to tangential acceleration. Okay, and in that the tangential acceleration is dv by dt. So you'll see that dv by dt will come out to be a negative quantity. So this equation becomes mg sin theta, the whole thing into sin beta minus 1 is equal to m dv by dt, or the rate of change of speed dv by dt is equal to g sin theta into sin beta minus 1. So in this, keep in mind one thing, that beta is a variable. Okay, it's instantaneous. Okay, and also sin beta in general is less than 1. Okay, and g sin theta is a constant. So this is not changing with respect to time. So you'll realize that we actually have something like this: dv by dt can be written as minus g sin theta into 1 minus sin beta, because sin beta is less than 1, so we'll have to treat it like this. So this is the rate of change of speed, not velocity but speed, because magnitude of velocity with respect to time. Okay, where beta is instantaneous, g sin theta is constant but beta is instantaneous. Okay, so make sure you understand this set of equations, then we'll proceed. Okay, so don't worry, not every question in friction is so lengthy and difficult. This is a one-off question, but this question will also help you understand a lot about general three-dimensional motion, curvilinear motion, and the application of kinematics with tangential and normal acceleration, etc. This is actually an Olympiad level question. This was taken from one of the Russian books called Krotov. Ekdam last parts, Nikita, this one, up to this equation is clear? Okay. So after this, all I have done is, देखो ये जो term है ना, ये negative term है ना, because sin beta is less than 1. So that's why I've taken the, this term is negative, so I've taken the minus sign outside. That's the only difference. And of course, I've cancelled m on both the sides. Is it clear now? Okay. So now obviously we have to solve this, but we have to solve this for which period of time? That becomes the important thing to understand. So to get that, we come back to trying to understand what happens further on. Now, we have only seen between some time 0 and some small amount of time t later, but we still have to see why the question has said long time later. Now, that means that this proceeds in such a way that after a certain amount of time, this situation is not so unpredictable. Right? It becomes something more stable. So let's understand what is happening that way. So the object started from here at t equal to 0, and how it's moving till it's turning, but at some stage you'll realize it's turned through 90 degrees. So somewhere here was our t equal to t, but at some stage, let's say it is deflected by 90 degrees. So the angular deflection has now become like this. So that point of time, okay, is some very large amount of time. So here you can see in the third diagram, what has happened is that beta has become 90 degrees. So it has deflected through 90 degrees. So at that stage, what is happening? Let's say the velocity is Vf. Now I'll tell you why it is Vf, because it will become a constant velocity. Now why it will become constant velocity is because of the value of coefficient of friction. Because जैसे ही मेरा velocity y axis के along हो जाएगा, क्या होगा? My mg sin theta and my friction, they will become anti-parallel vectors. Okay, so when this thing happens, mg sin theta and friction are at 180 degrees. So what happens is that the tangential acceleration becomes zero, and along with that the normal acceleration is also zero. Okay, so because not only they are at 180 degrees, and mg sin theta, kinetic friction, and the final velocities are collinear. Okay, so that is why the normal acceleration becomes zero, and because these two are at 180 degrees to each other, so the tangential acceleration becomes zero. Now mg sin theta minus kinetic friction, that is mass into tangential acceleration, but here mu is equal to tan theta. So the tangential acceleration becomes zero because these two cancel each other. Is this clear to all of you? Okay, so let us say the time when this is happening is some capital T. ये जो time है वो कुछ capital T हो गया. So let us say this third diagram is at T equal to capital T. So now see, our job is what? We want to find the final velocity, na? Because that is what the velocity will be after a long time. It's a constant velocity. Na? So what is happening is, see, once t is greater than capital T, the velocity remains final. Okay, it is a uniform 1D motion. Along the y-axis. This is what happens. And along the y-axis, the motion becomes uniform 1D. So I just want to find out, we want to find out Vf, because that will be the velocity after a long time. This only will be the velocity after a long time. So मुझे क्या करना है, ये जो equation था ऊपर, this one, this equation, I want to solve for Vf. Okay. So there are two problems for solving for Vf now. One is that we don't know this time capital T, and the other is beta is changing with time, so we don't know that. So that is where another trick will come into solving it. Okay. So the trick that will come into solving it is this, that we had dv by dt was minus g sine theta into 1 minus sine beta. This was the equation that we had. So cross multiply the time. We have this. Now integrate this. So when we integrate this, minus g sine theta is a constant. So just bring it outside. So this is beta. So this term is variable. Now this we are integrating from 0 to capital T, whatever that capital T time is. This is going from initial velocity to final speed Vf. Okay. So this left hand side becomes final speed minus V naught is equal to this right hand side, will be, which we'll just write as some variable, let's say phi. Okay. Where what is phi? Phi is this unknown quantity. Phi is 1 minus sine beta dt by integration from 0 to t. So it's an unknown quantity as of now. Okay. So we'll think of something else, that how we can use some other trick to find out the value of this integration. Okay. But this is where we reach up to with using this equation. Okay, so just make a note of this part, then I'll tell you how we will solve for phi. Okay, so next we will see another way to eliminate phi. We'll see that next. Okay, but write down up to here first. Okay, I'll show the. So this part, Nikita, this is the part you wanted to note down. Okay. All right. So are we clear up to this step now? To this step. Okay. So now let's see what is our alternate way of coming up with something for phi. Okay. So for that, we will go back to this free body diagram at time t. This one. Okay. Now, so I'll just copy this. Just this diagram I need. Okay. So in this diagram, if you notice, there's another significance of beta. Okay, and that is that if you divide the motion into x and y components, what is your net force along the y-axis? It should be equal to mass into y component of acceleration. Okay, so what is your net force along the y-axis? It is nothing but mg sine theta minus friction's sine beta component. Okay, so that should be equal to mass into y component of acceleration. So that is nothing but mg sine theta minus mu n sine beta, and we know that that is the same thing as mg sine theta, because this is tan theta into mg cos theta. Okay, so we get the very interesting result that g sine theta into 1 minus sine beta is actually the y component of acceleration. So this is something which is of great interest for us, because Next step, what we can do now is we can write ay as rate of change of y component of velocity, and that is nothing but g sine theta into 1 minus sine beta. So we have to integrate this thing now. We will get the same phi term that we had over there. So we'll have two equations with that variable phi. Okay, so if we integrate this now, so you can see that when it started the motion earlier on at t equal to 0, it had no y component of velocity. Vy was 0. Okay, and by the time it finishes up, wherever it is, its y component is only v final. At t equal to capital T, the y component is only v final. So if we integrate this, this will go from, so on this side time will be integrated from 0 to capital T, and on this side this will go from v naught to v final. So we will have v final minus v naught is equal to g sine theta into that same term phi, which is that integral term. We get this, okay, where phi is equal to this troublesome instantaneous quantity. So that troublesome quantity has to be eliminated. So we'll eliminate it between these two equations. The equations we wrote earlier and this equation. Okay. So just make a note of this and go through the steps. Let me know if there's a doubt with anything. From this step, we are going here. So this time, instead of resolving along tangential and normal direction, we are resolving along y-axis. So this is general Newton's second law is resolved along y-axis. There earlier what we had done was we had resolved F is equal to ma in tangential and centripetal or normal direction. Okay, this is what we had done earlier. So from this we had seen that our tangential acceleration was equal to g sine theta into sine beta minus 1. Okay, and our normal acceleration was g sine theta cos beta. So you see, if you compare this tangential acceleration and this y component of acceleration that we are getting here, you see there is a sort of a symmetry in it. There's a reverse symmetry. See this in this. Okay, so this is what we are taking advantage of. So integration of tangential acceleration with respect to time gives you change in speed. Okay. Whereas integration of y component of acceleration with respect to time gives you change in the y component of velocity. So this is what we are making use of, this and this. Okay. So now just solve this with the previous equation and see, you'll get an interesting answer. Okay. The previous equation which we had got by this integration. Oh, just a moment. There's one mistake here. This should not be v naught. This should be 0. See, because the y component of velocity, it's starting from a value of 0. Just a second. Just hang on. See, we are integrating the variable vy over here. So Vy का जो initial value है वो t0 पे कितना था? So that you can see in this diagram. Vy was 0 at t equal to 0. And in the final case is becoming how much? Vf. This should be equal to Vf. So our variable of integration is not the speed, it is Vy. So this is going from 0 to Vf. So this equation will become Vf is equal to this, where phi is the unknown. And the earlier equation had the relationship between these two. Okay. Okay. So let's go back to the earlier equation. It was giving me V final minus V naught is minus G sine theta into phi. So this equation was telling me that V final minus V naught is minus G sine theta into that term phi. And this one just now that I've solved, this is giving me that V final is G sine theta into phi, where phi is that complicated term. Phi is this term. So just solve these two now. Okay. So just substitute G sine theta into phi as V final and you'll get the answer. So you'll get V final minus V naught is minus V final. So you get V naught by 2. So you know what happens is it starts off with a speed V naught like this along the horizontal direction along the inclined plane and keeps turning, keeps turning, keeps turning till at some long enough time the velocity becomes, but by then this it has reduced to V naught by 2. Once this happens, it continues straight down with zero acceleration. All this while up to here it is having acceleration. All this while it is having both a normal acceleration and a tangential deceleration. It's having all this, but by the time it comes here, its acceleration becomes zero. So that's why it becomes a final velocity. Okay, so I mean, in a sense, this question is a little bit out of place here in this friction chapter because it is to do with the complexity of curvilinear motion also apart from frictional force. But anyhow, with your knowledge of normal and tangential acceleration, okay, it's easy to solve it. It's just very lengthy. This is not a JEE level question. Okay, you will not be asked things like this in JEE Advanced, let alone JEE Mains. This is a physics Olympiad level of question. But the reason why I'm discussing it is that it's an interesting problem to understand friction and also to understand your kinematics relations. So hope this is fully clear. Couple of you have asked me this question before and I asked you to wait till I discuss this in class. I think Kevin, you are one of them. So hope this is clear. Okay, good. Okay, so let's see. Maybe we can discuss some part of some question more today. I'm just going through the doubts you have sent me. Okay, so Manas, question number 78 you have asked. So let me see if we can quickly cover that today. Okay, so we'll discuss question number 29 from exercise 1. Since multiple people have asked this question, so let's wind up today with this question. Yeah. So this is like a bit of a logical type of question. So I want to discuss this. There's also a related question to this in H.C. Verma, that Superman problem in the friction chapter. So it says that, so exercise 1 from the module, question 29. So 3 or 4 people have asked this question. So I'm winding up with this today. So between the car and the ground, the coefficient of friction is mu. Okay. So we have to find out the minimum time in which the car can cover a given displacement of s. The minimum time in which car can cover a distance of x. Just covering this, the minimum time in which it can cover this. Okay. So for this, what we have to understand is that, as the car propels, usually it is a rear wheel drive car. So the axle of the car is given a transmission, so it has a tendency to rotate like this. So that generates a friction in the forward direction. And this friction is such that there is no slipping between the tire and the car. So this friction is less than equal to mu mg. Now how much it is, it actually depends on the amount of torque. So torque is a term we will understand fully in rotational mechanics, but it's a tendency to rotate, that is torque. So the more the power the engine is delivering, the more the torque is delivered to the wheel. So the more the amount of friction. So the net acceleration of the car just becomes this friction divided by mass. Okay. So as you can see, acceleration's maximum value is the maximum friction divided by mass. So maximum friction is the amount of friction that will tend to act when the tire is ready to skid. If you deliver torque more than that amount, so instead of the acceleration of the car increasing, the tire will start to skid and kinetic friction will start to act on it. So in fact, the acceleration will reduce a little because limiting static friction is more than the kinetic friction. So to achieve maximum acceleration, we have to deliver that amount of torque that generates maximum static friction without causing the tire to slip. Okay, so that's why this happens. So this is equal to mu g. So the maximum possible acceleration for a car, no matter how powerful the engine is, it depends on the friction between the tires and the road. It depends only on mu. Okay, and therefore the minimum time in which it can cover this will become square root of 2x or whatever divided by mu g. Okay, because obviously you're assuming you're starting from rest. Okay, and by the time you reach here, you have velocity v at t equal to t. So your displacement is equal to half at square. This equation we are using. So hope this is clear. Okay, people. So with this, we conclude today's session. Next session, we will be starting with work, power, energy. So please wind up all questions from the module exercises, in particular of friction, and keep sending me doubts. I will keep aside some time in the next lecture also for doubts. But we will be starting with work energy also. So we'll keep aside maybe 45 minutes or half an hour for discussion of doubts over the next 2 or 3 lectures, so you can finish off all this. Okay. So that's it for today's session, people. Any other doubts, you can send me on WhatsApp also. I'll keep sending you some hints. Otherwise, in the next session, we'll discuss.